right, everyone. I just wanted to give you a little bit more explanation into the worksheet that I'm getting you to work on Monday night. So if you go through the notes for this week, that's the YouTube video that I'm assigning you on Monday. You'll go through the steps to doing Lewis structures and how to determine their molecular geometries. So I just want to go through what exactly I expect to see in this table. You can see our first one is carbon dioxide. I chose that as our first one because it was an example in our notes as well. So first, for molecular name, I would expect that in that box, I would see carbon dioxide. Okay, that is the molecular name for that compound. Now, if a structure wasn't able to be named, I did put X's through that box. Okay. Now, for Lewis dot structure, it says to draw on a separate page. So on a separate sheet of paper, I would want to see a correct Lewis structure for carbon dioxide. Okay, you don't have the ability to draw these in your table, and so you're going to draw them on a separate sheet of paper and then upload those photos to me so I can see the steps by which you draw them. Now, for number of bonding regions, I'd be looking at here and here. And so if I were to be working on my document, I would be putting 2 in that box. Okay, that is the number of bonding regions. Now, if I look at this and I count how many of those bonding regions are lone pairs, we see that for this one, it's actually 0. So I'm going to be putting that in for number of lone pairs. So my total is now just going to be what I get when I add up my number of bonding regions and my number of lone pairs. So this ends up just being 2 as well. Now, we think about what geometry do I want to get these as far away from each other as possible. I would want them to be linear. That's based on my 2 domains. And for this one, since they're both bonding, the molecular geometry gets to be linear as well. When you're doing these for the other structures, remember electron geometries, there are only 3 options that you can have: linear, trigonal planar, and tetrahedral, because those are based on having all of your bonding regions be consisting of bonds and no lone pairs. When you get to molecular geometry, that's when we can see things like trigonal pyramidal and bent, because then it's just based on how many bonds you have and not the number of lone pairs. So hopefully this makes a little bit more sense. We want to make sure that we are typing the names of these correctly and keeping in mind, oh my goodness, all my typos, that we should not be capitalizing any part of the name. Okay, so hopefully this was helpful as you go to work through this table, and just let me know if you have any questions.